Hello and good day, pre-algebra. Today we will be talking about CO25, identifying the domain, which might be a new word for you, and range might be a new word for you, of a relation, which also might be a new mathematical word for you. So we're going to start by defining what each of those three things mean in the context of functions. Okay, we just came off of CO24 where we took situations, we made function tables, which really ties into a relation, because a relation is simply a collection of ordered pairs. A collection of ordered pairs. And this collection of ordered pairs can be represented as a table, which you see down below here, an XY table. It can be represented as a graph, which we're going to introduce here. Okay? So a relation is simply a collection of ordered pairs, and that can be represented as both a table and as a graph. The domain are the X values in a relation. Okay? And from PO24, we know that the X values are the inputs, also called the domain. The range are the Y values in a relation, also called the outputs. Okay, I'll add an S on here, inputs, there we go, make it match up. So outputs and inputs, domain and range, we've got different things that we can call these things, okay? So let's look at how to identify the domain and the range of a given relation, both as an XY table and on the coordinate plane. So I'm going to clear this ink. We're going to scroll on down the page here. All right, and we're going to start with a function table. And so a function table or an XY table, if the domain, as we defined it above, are simply the X values of the relation, the nice thing about a function table is that those inputs, those X values, are just listed for you. You know, we take a look at the table and I ask you, what is the domain? I'm asking you, what are the X values in the table? Your answer is just going to read them straight on down. -10, -5, 2, 4, 0. Are there more? Perhaps, that are not listed in the table, okay? But we can only work with what we have. And that would be the X values in the table. For the range, it's a similar thing. You know, the range of the function, the Y values of the function of the relation, what are they? Well, just look up there. -3, 0, 8, 2, and 1. Okay? So your method for a function table is you simply list the values because they are listed there for you. Right? When we move to the coordinate plane, a coordinate plane gives us a lot more information about the relation actually. Okay, because and I'm going to start by differentiating the two things that I have here, a line versus a segment. Notice that a line has arrows on each end of it. Okay, those arrows represent that line continues on forever in both directions. Whereas a segment, notice there are not arrows, but there are endpoints here. It means that it starts and it stops. It does not continue on. So all those years when your teacher has said, line up for outside, or line up for the bathroom, or line up for mass, really now you can raise your hand and respectfully say, well, actually, teacher, it's a segment. We should segment up because it has a beginning and an end. And then you might get pipped. I don't know. But anyway, so the key difference there, because when you talk about a line and talk about the X values that are included in this line, we can't just look at, you know, the X values on the X-axis here, -6, -5, -4, -3, -2, -1, 0, 1, and 2, almost a 3 here. We can't just list those out like we did in the function table. Because, you know, -4.5 is included on this line right here. Negative 1.1 is included on the line right there. 0.7 is included on the line right there, right? This line passes through all those decimals and all those fractions, and we have to include everything. Furthermore, because this line continues on forever in both directions, even the x value of 7, which if you look at it isn't on the line that's written here, if we continue this line onward, which is what that arrow says, now 7 will be on the line, right, as an x value. It's off the grid, but it's still there because the line goes on forever. So whenever you have a line on the coordinate plane, every x value and every y value are going to be included in the domain and the range. And so the symbol that we use, you might recognize this from equations, that double-stemmed R, that means that every x value is going to be included on this line because it goes on forever. Likewise, every y value is going to be included on the line because it goes on forever. Okay? So for a line, your answers are always going to be all reals or everything because those lines go on forever. For a segment, because it has a beginning and an end, if you look on the x-axis here, I'll do it in red, where this segment kind of starts, the first x value in this segment is at -1, right? Because the segment starts here, we kind of look down, okay? -1 is the very first x. That's where our domain starts. Our domain ends at 5 on the x-axis, right? Because the 7 goes between -1 and 5. It doesn't get to 6 because it doesn't go on forever. It stops. It doesn't get to -2, right? Because it stops. So in this case, the domain of a segment, we can't list -1, 0, 1, 2, 3, 4, and 5, because like a line, it does include things like -0.5, positive 2.1, right? Everything on this x-axis between -1 and 5 is represented on the segment. So we have to give it a little bit of a range. What is the domain? Well, the domain is from -1 to 5, right? Every x value from -1 to 5 is included. The range, looking at the y-axis, and I'll do this in blue here, what's the lowest, the highest, and the lowest this segment goes? Well, the highest it goes is 7, right there, and then it goes all the way down, every y value is included all the way down to +1, which is the lowest it goes. Okay, so the range of this segment, what y values are included? Everything from 1 to 7. If you put 7 to 1, that would be fine also. Okay, but 1 to 7. Going on down a little bit further here. And so before I clear this thing, please get the kind of the quirks of each type of relation here. For an XY table, you'll always be listing the values. Okay. For a line, your answer is always going to be that all reals symbol because it goes on forever. For a segment, I don't want to say you are looking for a range, but you're going to have a beginning and an end. I didn't want to use the word range because the word range is kind of one of the things that we're trying to find, and it means something specific. But you're going to have a beginning and an end. What is the beginning x, the end x, the beginning y, the end y? There'll be one of each of those types on your test. Okay. Scrolling down, write the domain and the range of the line or the segment. Graphs are historically the more challenging of the two types because sometimes people don't look for the arrows. They miss the arrows that make it a line. They list the values like as if it were a function table. That's not what we're doing here, right? This is a coordinate plane, a graph, we have to include all those decimals, all those fractions, okay? So looking at this first one, we first need to decide, is it a segment or is it a line? It is a segment because it has endpoints, right? They're not as obvious as it was in the example, but there are clearly no arrows here, okay? It clearly starts there and it stops there. So because it's a segment, we're looking for a beginning and we're looking for an end. So just like before, in red will be my domain. Where on the x-axis does this segment begin? What's the first x value that it contains? Well, it looks like it starts right here at -4. It continues on, goes through past 0, and the highest x value that we have is +5. So the domain is from -4 to 5. Those are all the x values that are included. The range, where on the y-axis does this segment go? Well, not very far on the y-axis. It's not very steep. So it's the lowest y value that it has is +1, and it only goes up to +3. Okay? So the range is going to be from 1 to 3. The y values that are included. You'll need this 3-digit code for the quiz. It is 722. Your 3-digit code is 722. The next one, a line. And I know that because it has those arrows on each end, right? And so I look at my notes up above. I say, okay, what about a line? Oh, yeah. Oops, I almost wrote the word line. The domain of a line is always going to be everything, because every x value is going to be included. On the graph here, it looks like we only go from -4 to -2, but then remember that this continues on and on and on and on, so it will include -5, -6, -7, -8, so on and so forth. Okay. Similar for the range. It's going to hit every y value at some point because it continues on and on and on. So that will be all reals as well. And that'll be consistent for every single line that you come across. The last one, look at it. Segment or line? No arrows, got to be a segment. Okay. Draw my endpoints in here, just for good measure, right? So on the x-axis, our domain, this line starts at -4, is the lowest one there, and it goes to -1. Every x value is contained between -4 and -1. So -4 to -1 for my domain. The range, switch to blue here. Let's see, the lowest y value it has is 0, and it goes all the way up to +5. Everything is contained between 0 and 5 on the y-axis. So the range is going to be 0 to 5. All right? I asked for questions, but there's no one here to answer me, so we'll assume that everything's good. Take a look at the second page. I don't know if I want to do this one. No, I do not. Okay, so that wraps up the lesson for CO25. You do have a Google quiz to complete over in Google Classroom, and it's posted there for you. Make sure you are getting 100% on that. If you'd like to Zoom, if you got questions on this and would like to Zoom with me, my office hours begin at 1:30. I'll post a link in Google Classroom at 1:30 for you to come Zoom with me. But otherwise, this wraps up our week of distance learning. Wasn't that fun? Khan Academy will be assigned today, which is due next Thursday, so have that on your radar as well. But I will see you back live in person on Monday. Looking forward to it. Have a great weekend, folks. Don't forget to like and subscribe, and be well.